Hello guys, this is Nate, and today I have planned to discuss about displacement and distance. So we will do our tutorial by answering some questions. The first question will be, what's the difference between distance and displacement of an object? Okay, I will try to use very short phrases to explain both. When I say distance, it is the actual length an object travels, and when I say displacement, it is just, you should keep this in your mind, just the difference or the length between the initial and final positions of an object. Positions of an object. When we say is, what do we mean? Okay, to explain this using a diagram, let me use like this one. Let's say here is a road like this. Okay, we do have a road that comes straight and turns like 90 degrees, and let's assume a car starts to move from here. Okay, this is the car. I don't know, it's bad drawing. Okay, this is the car. The car moves all these paths and it turns, and again it comes to stop here. Okay, so now we are asked to find, okay, let's put the dimensions here. From this side is like 30 kilometers, and let's say this side is 40 kilometers. Okay, so if we are asked to find the distance, we just count all the distance that the car traveled. So in this case it will be what? The car started from here, it traveled all these 30 kilometers, and again it traveled this 40 kilometers. So the car traveled distance equals to 30 kilometers, and it again traveled 40 kilometers. So the actual distance is, or the length that the car traveled is exactly 70 kilometers. However, if we try to find the displacement, it says it's just the length between the initial and final positions of an object. While doing the displacement, we just need to consider two positions or two places only, 2 points, and it is the initial point and the final point. But before that, I need to clarify something, and let me use this color. When we say the length here, this length, I will bring it here, this length, this should be straight line, and it is the shortest possible, and this is the only possible line. Why I'm saying this is because if we duplicate this path here, the car started to move from here, right? Okay, and it stopped here. When we talk about displacement, we don't need to consider all the paths it traveled. We just need to know where it started and where it stopped. So the displacement will be, it is starting point, and this is stopping, and it stopped here. So when we say displacement, it is the distance from here to here. But any one of you may think like we can connect these points like this one, like this, or like this. So that's why I have said it must be a straight line. It should be from here to here, straight line, and it must be the shortest possible, and we do have only one possible line. That's why. So when we explain displacement, we may include like it's displacement is displacement is the shortest possible straight line, the shortest possible straight line that connects starting to stopping positions. Okay, so let's solve this one at the end. What is the displacement of this object? Meters, and this is 40 kilometers. So what's the displacement? The displacement will be 30 here and 40 here, and from starting to finishing is the displacement. So the displacement will be, we will apply the Pythagoras theorem, right? So displacement will equal to square root of 30 square plus 40 square, and this would be 900 plus 1600, and this would be square root of 2500. At last this would be 50 kilometers. But it's not only this. When we talk about distance and displacement, this is not the only difference. This is not the only difference, because they share the same unit. If you talk about unit, distance, it is meters, and for displacement also the same meters. But where do we have a difference here? Distance, no direction, whereas in displacement we need direction. For instance, in the examples that we have been talking about, the path was like this, and the car started from here and it stopped here. When we talk about the distance, we don't care the direction it traveled to. So it started from here and it stopped here. We don't care about the direction in distance. We just need the length of the path it traveled. However, in displacement, we need to know the direction, and I just bring the starting point here, and this is the stopping point. So when I talk about displacement, I have to address the stopping position to the starting position. So it started here and it stopped here. If I bring the graph, so this would be from starting to stopping would be here. So I need to know this theta, this angle, and I will use this angle as an address. So theta will be, I know this distance, right? It is 40 kilometers, and I know this distance, right? It is 30 kilometers. And also I know this one. I can also use this one, but it's better to use the dimensions that were given at the start. So theta will be tan inverse of 40 over 30, right? So theta 1.333, right? Okay, so theta would be 53 degrees. Theta is 53 degrees. So what do you mean by 53 degrees? When I write the final answer, I will write it: displacement is 50 kilometers, comma, I need to write this direction, 53 degrees. So 53 degrees what? This is 50 degrees. 53 degrees, it is south of east. This is east, right? West, north, and south. So 53 degrees south of east. I write it south of east. This is the displacement. However, when I write distance, I would just write the distance traveled is 30 plus 40, just 70 kilometers. I don't need to specify the direction. Okay. Continuing to this, continuing from this, we will discuss this question, and it says, when is distance traveled and displacement of an object equal? Okay, what can you say about distance traveled and displacement of an object? To understand this one first, as the previous example, we took a path that was like this, and it was obvious that the distance and displacement would not be equal. So the distance was this one 30 kilometer and this one 40 kilometer. The distance was 30 plus 40. 30 plus 40, it was 70. And even if, for instance, let's take here a semicircular path. Okay, if we took this semicircular path, and if a car starts to move from here and it travels all the way to here and stops here, okay, so what would be the distance? What would be the distance and displacement? Okay, so when I talk about distance, it will be all the paths is traveled right here, right up to here. So the distance would be, distance would be all the lengths. And if we notice it, this is semicircle, and if it was a circle, and if we notice is this is semicircle, so if it was a complete circle, we would find the distance, all the distance, by the same circumference. Circumference would be 2 pi r, right? But here it is semicircle, so if we assume that the radius of this circle was 7 kilometers, so circumference would be 2 pi r for the whole circle, but this is semicircle, so I would need to divide it by 2. Circumference would be pi times r only. Pi is 22 by 7 times radius is 7 kilometers, so circumference would be 22 kilometers. So what is this? This length is just 22 kilometers. Distance would be 22 kilometers. However, when I calculate the displacement, I would just need to consider the initial position and the last position. And when I do that, I just know from here to here, I need the straight line, the shortest straight possible line that connects the starting position and the stopping position, and it is the diameter, if you can notice it. So the diameter is just radius times 2, and radius is here 7 kilometers times 2 is 14 kilometers. In this case also, displacement and distance are different numbers, so we'll consider, if we take another example also, we may find the displacement and distance to be different. However, there are few cases, or there is a case where we can get the displacement and distance to be equal, and we are asked to find it here. Okay, to go to the solution, it is like this. If we have a straight path and an object starts to move from here and it moves up to here, let's say this is 40 kilometers. Done. Distance is all the position it traveled, and it traveled 40 kilometers, so distance would be just 40 kilometers. And when we go to displacement, it's just the difference between the difference in position between the starting point and stopping point, right? And from starting to stopping here is 40 kilometers again, so displacement would also be the same, 40 kilometers. So what is the answer for this question? When is distance traveled and displacement of an object equal? The distance traveled and the displacement of an object are equal if the path is straight. If the path is straight. So this is the answer. Okay, let me erase this right in here. And the next question says, is distance a vector or scalar? Okay, to answer this question, we first need to understand the difference between scalar and vector. It's a very simple concept, and when we say scalar, it is magnitude only, and when we say vector, it is magnitude and direction. So when I write distance, in some books we may find it like D, or in some like S, and when we write displacement, it may be like D with an arrow ahead in the head, and when we say the same case, if we use S, it should have an arrow here, and this arrow specified that it needs direction. Okay, So continuing from this, when you talk about the question is, okay, continuing from this, the question is distance vector or scalar? In the previous portion we just discussed that we don't need to specify the direction when we talk about distance, so distance is just scalar, we just need to specify the magnitude only. However, displacement is a vector, because in displacement we need to specify the direction. For example, here when we did the displacement, we just calculated it 14 kilometers, but here we didn't specify the direction, but we had to. And let's specify the direction now. The starting position is here, the stopping position is here. So if I go to graph, starting here, stopping here, so what is the angle? No angle, it is 0 degree, like the same. So if it is the same, I don't need to specify the angle, or I can just write 0 degree, but I don't need to, so I can write just to east.